The construction industry is changing faster than at any time in history. Robots are laying bricks. Autonomous excavators are digging foundations. Artificial intelligence is analyzing construction schedules faster than any human project manager ever could. For the first time in history, machines are beginning to do the work builders have done for centuries. Welcome to the era of the last human builder. For decades, construction has been one of the least productive major industries in the world. While manufacturing, agriculture, and technology experienced massive productivity gains over the past 50 years, construction productivity has barely moved. In some cases, it's actually declined. Now a wave of automation is beginning to transform the job site. Robots, artificial intelligence, autonomous machines. Technologies that once sounded like science fiction are already working on construction projects around the world. Which raises a very important question. Where does that leave the human builder? Because buildings don't fail when the math is wrong. They fail when reality doesn't match the model. And that is where the last human builder may still matter more than anyone expects. There is a robot named Sam. Sam doesn't complain about the weather. Sam doesn't take lunch breaks. Sam doesn't take days off. Sam just lays bricks. Hour after hour. Day after day. 3,000 perfectly placed bricks every single day. A skilled human mason, on a really good day, might lay 500. On average, it's closer to 300. Sam isn't the future of construction. Sam is the present. And Sam is just the beginning. But Sam didn't appear out of nowhere. Sam exists because construction has a problem. Actually, several problems. Let's start with construction's dirty little secret. It's the least productive major industry in the world. There, I said it. Think about that for a second. Every other major industry has become dramatically more efficient over the past 50 years. Manufacturing revolutionized production. Agriculture feeds billions with fewer workers than ever before. Technology transformed the global economy. But construction? Construction productivity has barely moved since the 1970s. In some cases, it's actually gotten worse. We're building things slower today than we did decades ago. How is that even possible? Simple. Construction is like that friend who still uses a flip phone, stubbornly resistant to change. While other industries embraced automation, robotics, and advanced technology, construction continued to rely on the same basic process. Human labor. On a job site. Building piece by piece. Sure, the tools improved. Power tools replaced hand tools. Cranes grew larger. Equipment became more powerful. But the fundamental method never changed. Humans building structures manually in environments that change every single day. And now the industry is paying the price. Because the workforce itself is disappearing. By 2030, nearly half of the construction workforce is expected to retire. Millions of skilled tradespeople leaving the industry. Decades of knowledge walking off the job site. And the next generation? They're not lining up to replace them. Trade school enrollment has been declining for years. Young workers are choosing different careers. Careers that are safer, easier, and often better paid. Meanwhile, the demand for construction is exploding. Infrastructure needs rebuilding. Housing shortages are growing in cities around the world. Climate adaptation requires massive new projects. The world needs more construction than ever before. But there are fewer builders, less productivity, and increasing demand. That's not just a challenge. It's a crisis. And into that crisis stepped Sam. And Sam isn't appearing in a vacuum. He's arriving at a moment when construction desperately needs help. Because the workforce that built the modern world is retiring. By the end of this decade, nearly half of the construction workforce in the United States will reach retirement age. Think about what that means. Millions of skilled tradespeople leaving the industry. Electricians, ironworkers, carpenters, plumbers, masons. Workers who spent decades learning how buildings actually come together. Knowledge that can't be downloaded. Knowledge that can't be replaced overnight. When these workers retire, they take something with them. Experience. The kind of experience that only comes from years on the job site. knowing when concrete is curing too quickly, recognizing when soil conditions don't match the report, understanding when something just doesn't look right, and the next generation isn't replacing them fast enough. For years, young people were told that success meant leaving the trades behind. Go to college, work in an office, build a career behind a desk. Meanwhile, the people who actually build the world were quietly getting older. Trade school enrollment dropped. Apprenticeships struggled to attract workers, and construction slowly began running out of builders. Today, the industry already faces hundreds of thousands of unfilled positions, and the gap is growing. At the same time, demand for construction is exploding. Infrastructure needs rebuilding. Housing shortages are growing in cities across the world. New energy systems must be built. Climate adaptation will require massive new projects. The world needs more construction than ever before. But there are fewer people to build it. Less labor, less experience, and more work than ever. Something has to fill that gap. And increasingly, that something is machines. SAM was only the beginning. Across construction sites around the world, machines are quietly learning how to do the work builders have done for generations. Take Hadrian X. Hadrian X doesn't assist bricklayers. It replaces the entire process. Mounted on a truck with a massive robotic arm, the system reads digital construction drawings and converts them directly into building instructions. Brick, mortar, placement. Again, and again. Up to 1,000 bricks per hour. A pace no human crew can match. But robots aren't just building structures. They're watching them too. Meet Spot. Spot walks construction sites every day. Climbing stairs. Navigating obstacles. Scanning the entire project with cameras and laser sensors. Capturing thousands of images and measurements. Then comparing the real structure to the digital building model. If something is out of place, Spot finds it. What might take a human inspector days to document, Spot can capture in a matter of hours. And the data is instantly shared with the entire project team. Other robots focus on precision. Take Dusty. Dusty doesn't build walls. Dusty prints them. Using digital building models, Dusty drives across concrete floors printing the exact layout of walls, doors, plumbing, and electrical systems directly onto the slab. Every measurement pulled directly from the digital design. Perfectly aligned. No tape measures. No chalk lines. No guesswork. Then there are machines doing the work that destroys human bodies over time. Like tying rebar. On bridge decks and massive concrete structures, thousands of steel intersections must be tied together by hand. Hour after hour. Bent over steel. Now robots like TieBot crawl across the grid automatically tying thousands of intersections with perfect consistency. No fatigue. No injury. No slowing down. And the machines are getting bigger. Excavators that dig foundations by themselves. Bulldozers that grade entire sites automatically. Haul trucks that move materials without drivers. These machines use GPS, LiDAR, and computer vision to understand the terrain around them. They know where to dig. They know how deep to go. They know how to avoid obstacles. And they can work all day, every day, without stopping. For the first time in history, construction machines aren't just tools. They're becoming workers. But the real revolution in construction isn't the robots you can see. It's the intelligence you can't. While machines are learning how to build structures on the job site, artificial intelligence is quietly learning how to run the project itself. Take trunk tools. Modern construction projects generate enormous amounts of information. Specifications, submittals, RFIs, safety plans, contracts, thousands of pages of documentation for a single project. Finding the right piece of information can take hours, sometimes days. Trunk Tools uses artificial intelligence to search construction knowledge instantly. Ask a question. The system scans the entire project documentation and returns the answer in seconds. No digging through binders. No scrolling through hundreds of pages of specifications. Just the information you need, exactly when you need it. And Trunk Tools is just one example. Across the industry, artificial intelligence is beginning to take on the mental work that once belonged to project teams. Estimating, scheduling, document management, risk analysis. Systems are now capable of analyzing drawings, identifying conflicts, predicting delays, and optimizing schedules faster than any human planner. What used to take teams of people weeks to calculate can now happen in minutes. And as these systems learn from more projects, they get better, faster, more accurate. The machines on the job site are learning how to build, but the software behind the scenes is learning how to think. And when those two worlds connect, construction begins to change in a way it never has before. Toggle AI, another area where artificial intelligence is transforming. Construction is estimating. For decades, estimating a construction project meant hours of manual takeoffs. Blueprints spread across tables, highlighters, calculators. Estimators carefully measuring walls, slabs, doors, windows, pipes, and fixtures. One detail at a time, one drawing at a time. On large projects, that process could take weeks. Now systems like Toggle AI are beginning to change that. Toggle AI analyzes construction drawings automatically. Upload a set of plans, and the system can identify building components, measure quantities, and generate detailed takeoffs in minutes. Walls, doors, windows, structural elements. Material quantities that once required hours of careful measurement can now be calculated almost instantly. The estimator still makes the final decisions, but the heavy lifting, the measurements, the counting, the pattern recognition, is increasingly handled by artificial intelligence. What used to take days can now happen in minutes. And the technology is improving with every project. The machines on the job site are learning how to build. The software in the office is learning how to plan. And when those systems begin working together, construction stops being just a collection of tasks. It becomes a coordinated system. But artificial intelligence isn't just helping estimate projects, it's beginning to plan them too. Construction scheduling has always been one of the most complex challenges in the industry. Hundreds of tasks, dozens of subcontractors, materials that must arrive at exactly the right moment, weather delays, equipment availability. One small change can ripple through the entire project schedule. Traditionally, these schedules are built by experienced project managers using software tools and years of intuition. But artificial intelligence is starting to approach the problem differently. Systems like Alice Technologies analyze construction schedules using advanced algorithms. Instead of calculating a single construction sequence, Alice can generate thousands of possible schedules, each one optimized for different priorities: speed, cost, labor availability, risk reduction. The system analyzes how changing one task affects the entire project timeline. Move one activity forward by 2 days. Delay another by 3. Resequence multiple crews. What might save 2 weeks on the overall schedule? What might reduce risk? What might lower cost? These are patterns that are difficult for humans to see, but artificial intelligence can evaluate them in seconds. For the first time, construction schedules aren't just being created, they're being optimized. Open space artificial intelligence is also changing how construction projects are documented. Traditionally, documenting a job site meant walking the site with a camera, taking photos, writing notes, trying to remember exactly what the structure looked like weeks or months later. But construction projects change every day. Walls go up, systems get installed, concrete gets poured, and once something is covered up, it can be difficult to prove what was actually built. Now, artificial intelligence is helping capture the entire job site automatically. Platforms like OpenSpace use computer vision to create a visual record of the project. A worker walks the site wearing a small 360-degree camera on their hard hat. As they move through the building, the system captures thousands of images. Artificial intelligence then maps those images directly onto the project drawings, creating a visual timeline of the entire construction process. Any moment in time, any location in the building, every wall, every pipe, every installation. all searchable instantly. What once required teams of people and weeks of documentation can now happen automatically during a normal site walk. The job site is no longer just being built. It's being recorded, analyzed, and understood in ways that were never possible before. Up to this point, every system we've talked about solves a single problem. One robot lays bricks. Another robot ties rebar. Artificial intelligence analyzes schedules. Software goes through project documentation. Computer vision records the job site. Each technology solves one piece of the construction puzzle. But construction projects aren't made of single tasks. They're made of thousands of decisions, thousands of moving parts, materials arriving at the right moment, crews working in the correct sequence, equipment moving through constantly changing environments. For more than a century, coordinating all of that complexity has required human judgment. Superintendents, project managers, foremen, people walking the site and making decisions in real time. But what happens when the coordination itself becomes automated? Imagine a system that can see everything happening on a job site. Drones scanning the project daily. Robots collecting measurements every hour. Cameras documenting every phase of construction. Sensors tracking equipment and materials across the site. Now imagine feeding all of that information into one intelligence. An intelligence capable of analyzing the entire project in real time. Every schedule change. Every material delivery. Every progress update. Patterns that humans might miss suddenly become obvious. Move this crew 2 days earlier. Delay that delivery by 6 hours. Resequence these tasks. Shift the excavation phase. Decisions that might take humans hours or days to analyze could happen instantly. This idea is what we'll call Zyrex. Zyrex isn't a robot. Zyrex doesn't swing a hammer. Zyrex doesn't pour concrete. Zyrex coordinates everything. Robots build. Machines move earth. Artificial intelligence analyzes schedules. Computer vision monitors the job site. And Zyrex connects them all, quietly optimizing the entire project. At first, humans still oversee the system, reviewing the plans, approving the schedules, supervising the machines. But over time, something interesting begins to happen. The system gets smarter. The data gets better. The decisions get faster, more precise, more efficient. And slowly, very slowly, humans begin stepping back. Not because they were forced out, because the system works. Projects finish faster. Costs drop. Schedules become predictable. Accidents decrease. Developers notice. Governments notice. Investors notice. And once the industry realizes it can build faster, cheaper, and safer with systems like this, there is no going back. Construction begins to change in a way it never has before. But there is one question hiding inside all of this progress. A question almost nobody in the industry is asking. If robots can build the structure, if artificial intelligence can schedule the work, if machines can monitor the entire job site, if systems like Zyrex can coordinate the entire project, what exactly is left for the human builder? For centuries, buildings were created by human hands. Builders who understood materials. Builders who understood structures. Builders who understood something machines still struggle with. Reality. Construction sites are messy places. Concrete cures differently depending on the weather. Soil conditions shift. Materials arrive warped. Schedules collide with unexpected problems. Reality refuses to follow the model. Robots can place bricks. Artificial intelligence can optimize schedules. Algorithms can analyze drawings and predict delays. Machines can even build entire houses. But construction isn't just about assembling parts. It's about judgment, leadership, knowing what the customer wants, responsibility. Someone still has to run the preparatory meetings. Someone still has to coordinate subcontractors. Someone still has to verify the testing, concrete samples, soil reports, lab results. Quality control doesn't happen automatically. A QC manager still has to ensure the work meets the specifications. Someone still has to walk the job site, look at the structure, ask questions, and decide whether something is right. Even the most advanced technology still requires people. People to fly the drones, people to interpret the data, people to make the final call when something unexpected happens. Because machines can calculate, but builders understand. The future of construction may include robots. Artificial intelligence may transform how projects are planned and executed. But the builders who learn to work with these tools, the builders who combine experience with technology, may become more valuable than ever before. Because buildings don't fail when math is wrong. They fail when reality doesn't match the model. And when that moment comes, someone still has to understand both worlds: the technology and the job site. The future of construction may not eliminate builders. It may simply create a new kind of builder, the one who understands the machines and the reality they operate in, the last human builder.